Okay, I don't think I'm hearing myself anymore. Nope. Okay, so this is what happens. This is why I was hearing myself. I have my hearing aids in underneath my headphones. My phone Bluetooths to my hearing aids. On my phone over here, I have my stream so I can see what you guys are seeing. And so I was hearing from my phone on my Bluetooth hearing aids within my within my headset. So weird, very weird. Okay, so nice to see you guys. Hopefully we'll do some good review here. I opened the calculator in case I can show you guys anything on the calculator, but I'll minimize that because we don't really need that right now. If you have a question, put it in the chat. The chat is a slight delay, so it's going to take me a second to see your question sometimes from the stream. So just know that. Okay, I'll see your question eventually. Um, okay, so I'm going to just go through each of the questions about the 10 questions on that chapter 14, 15 review. Then I'll clip it and then I'll post it on YouTube. So if you can't be here, you're ready to go. Oh, there we go. He's not in the class, but he's ready to learn. Let's do it. Let's do it. Okay. Um, First one here. Let's read through it. Complex electronic device contains three components, A, B, and C. The probabilities of failure for each component in any one year are 0.01. Probably should use the highlighter. 0.01, 0.03, and 0.04. Okay, so they have to succeed in order, right? That's the probability that they will fail that year. If any one component fails, the device will fail. So we need all of the components to work the whole year or this device fails. If all the components fail independently of one another, what is the probability that the device will not fail in 1 year? So they are basically asking you to calculate the probability that the device is going to work for the year. The only way this device works is if all three components work. So we need A to work and B to work and C to work. Okay, not to fail, you need them to work. So that's going to be 0.01. No, sorry, that's failure rate. Failure rate, see, this is the common things that people are going to do. Success rate, 0.99 for component A. For component B, success rate, 0.97. And for component C, success rate, 0.96. Why are we multiplying them? Because you need A to work, and you need B to work, and you need C to work. Just doing, these are this is a chapter 14 problem. You're just doing the and problem before you knew about all the complications. So you're just going to multiply the three probabilities. So 0.99 times 0.97 times 0.96, 0.92188. So 921, I'm just going to round it to like 9, right? Close enough. So they said 0.922. So that is the correct answer for that one. Where do the other ones come from? I bet you there's one of these. I bet you is if you multiply the 0.01, 0.03, and 0.04. I would bet that is a super common wrong answer. Less than 1%. So A is if you multiply those three, that will be the A. If you multiply those three and you did one minus, you would pick 0.9999968. So maybe you pick E if you're like, oh, I'm going to do those three failing, and then I'm going to do the opposite and do one minus those three failing. That's not what this is asking the way they explained it. So there's that one. A chapter 14 problem, not as much a chapter 15 problem. But people want to get it crazy. You guys don't overcomplicate everything. Some of them are supposed to be just chapter 14 problems. So sometimes it's not a Venn, sometimes it's not a tree, sometimes it's just going to be multiply, just an and. Sometimes it's just going to be an or, and there's no overlap. So you're just going to add things. Don't freak it out. Okay, don't get too crazy on it. Okay, so done with that one. Well, let's go to number two. Um, okay, number two. Be cool if I could make this a little bigger. It looks so strong. Can you guys see it okay? Because it looks really small on my Streamlabs, but on my main screen it looks okay for me. Okay, you got to. Thank you. Um, okay, so this one is the one I talked to a lot of you about in class today. This is actually a chapter 15 problem. So here we go. All bags entering research facility are screened. 97% of the bags that contain forbidden material trigger an alarm. Hold that number, 97% trigger an alarm if they have bad material. 15% of the bags that do not contain forbidden material also trigger the alarm. So those are your false positives. If 1 out of every 1,000 bags entering the building contains forbidden material, what is the probability that a bag triggers the alarm? That triggers the alarm. So this is, we know the bag triggered the alarm. So that is our given. They told you the bag triggered the alarm. That is the given. So they are asking you to calculate the probability that the bag actually contains forbidden material given that it triggered the alarm. So that's the first part. Like you can't do this problem if you don't know what it's asking. Okay. So you've got to write. I write that out. You don't. I told you it's not required. It's a communication piece, but I think it helps me know because once you know what these two are, then you know this is the first step. You can't do this problem if you don't know what the trigger rate is going to be for the overall problem. So, first level of this tree, do you have forbidden material or do you not? First level. So, what percent after they said 1 out of every 1,000 has forbidden material. So, 1 out of every 1,000 is your 0.001. Okay, I should have known that without a calculator, but oh well. And then that means the opposite of that is 0.999. So this branch 0.999. Okay. Second level, you either trigger or you don't. T is going to be my trigger. Trigger the alarm or you don't. So they told you that in 97% of the bags that contain forbidden material will trigger. So if you have bad material, we will catch you 97% of the time, which means 3% of the time we won't catch you. And then on the other branch, 15% of the bags that do not contain forbidden material also trigger the alarm. There is a false positive rate of 15%, which means the correct not triggering is 85%. Okay, so you have all your things. Hold on, let me dismiss this ad. I don't want an ad break, we're dismissing. Okay, so we got our setup for our table. We would like to calculate the two branches where we trigger the alarm. So this branch and this branch are the two you want to calculate. So since I want to calculate those, I'm going to do 0.001 times 0.97. That will give you the rate on that one. 0.999 times 0.15. So there's your rate on that one. So you got to get your two trigger rates. So that times 0.97, it's a small number. 9.7 times 10 to the negative fourth. And then the other one, 0.999 times 0.15. 0.149 0.85. Take those two numbers, add them together, because it could be you triggered the alarm this way or you triggered the alarm that way. So just use your calculator, don't retype it. Add them together. So the probability that we trigger the alarm is 0.15082, straight from your calculator screen. So that's your trigger rate. That is going to be the bottom number for what we want to calculate. So we're going to calculate the probability that we forbidden. So that's going to be which one of these was the forbidden one. So you look at it and you're like, oh, I'm looking at my two branches. The forbidden one was you had bad material and you triggered the alarm. That is this one. So you are going to put that number on top, 9.7, 10 to the negative fourth, divided by the overall trigger percentage, and then boom, that is going to be your answer. So you do that rate divided by the 0.15, you should get 0.00643. This is a crazy number on this one. So the correct answer is this one. And if you, the crazy thing is, look at this. Chances are, if you trigger the alarm, you actually don't have something, because most of the alarms that are triggered are the ones that don't have anything because the false positive rate is so high. So it's crazy. So think about this. You're working TSA, the alarm gets triggered, like let's say the metal detector gets triggered. Most of the time, you don't have anything forbidden because it just triggers off of so many things, right? So that's sort of, it's crazy. But yeah, that's why there's a second level of check probably, because false positives are going to happen. Um, so there's your chance on that one. Pretty good problem. That's actually a really nice problem. That's actually a really good FRQ problem. You don't see a lot of those on multiple choice, but that was one I found. So I went ahead and gave it to you guys. Okay. If there's a question, throw it in the chat. Don't be shy. If you're watching, you can totally throw it in the chat. Okay, I can see the chat here. Okay, next one. Number 3. Okay, so this one's, it can be a really complicated problem or it can be, you can make it easier. So I'm just going to use the formula. There is the formula. It is going to be written on the board for the test, but there is a formula, right, that says the probability of A given B is the probability of A and B. This is the Bayes theorem formula, divided by the probability of the given, which is the probability of B. That's the same formula we just used on the last problem. Ooh, ad break. We don't want an ad. What? I didn't catch the ad. Sorry about the ad, guys. I was so involved in the problem, I did not see that there was an ad. So you probably missed part of that problem. So let's go back. Calculated the trigger, calculated the trigger rate on that branch, add them together because you don't know which branch it happened on. There's your overall trigger rate. That's going to be the bottom number. The top number is going to be the one that actually had forbidden material, which is this tiny one. That's going to go on top. Divide those. There's the chance that someone triggers the alarm and they actually have something forbidden in their bag. That's the answer B on that one. So in case you missed it over the break, sorry. I gotta see that when the ad comes. Okay, so that's the bad part of Twitch. It requires ads and, you know, pays for part of the stuff. Okay, so here's the formula we can use to do this problem. Why did I pick that formula? Well, because I noticed I had the conditional probability there and I had the and probability here. So when I noticed I had both of those, I thought, maybe we're using this formula And I'm hoping they're going to ask me for that one. So let's see. They said to you, A is student is a student athlete, B is that they drive to school. So this is the chance you're a student athlete and you drive to school, 8%. This is the chance that you drive to school given you're a student athlete. And then they want to know the probability that the selected student is a student athlete. That's the bottom number. So they just have it written, turned around a little bit. So if they write it probability B given A, then the top is still your and. You can just write B and A. It doesn't really matter the order the and goes. And then the bottom is going to be the probability of A, because that's the given that goes on the bottom. So plug in your numbers. This is 0.25. This one on top is 0.08. You're figuring out this one, we'll call it X. So solve your algebra, cross multiply there, divide by 0.25, and there's your answer. 0.08 divided by 0.25. 0.32. There's the right one for that problem. So 0.32 on that one. Is there another way to do it? Yes, you could draw a tree. I show you over here. The tree could be you're a student athlete or not. And then the second level would be you drive to school or not, or you drive to school, right? Or you don't. So what did they tell you in this problem? Well, they told you the chance that you drive to school, given you're a student athlete, is 0.25. So they gave you this probability. The chance you're a student athlete and you drive to school is 0.08. Well, that's the answer you get if you calculate that top branch, right? If you calculate this times this, it will be the 0.08. So they didn't give you the probability that you're a student athlete. Notice it's the same formula here. You do this times this, you will get that. Basically what we did there. So 0.08 divided by 0.25 will give you the X. So there's a way to do it on the tree. You didn't need the whole tree. So that's why I used the formula, but you could use the whole tree if you wanted to and just focus on that top branch and you don't care about the rest of it. Questions, questions. Oh, I can't sing. Tell me not to sing. That's terrible. That was terrible singing. Terrible singing. 6 of you enjoying this live stream. I'm glad you're here. Okay. It's no fun to do videos for nobody watching. I'll tell you that right now. So, good thing we have you here, and then I'll post it for everyone else. So, here we go. Next one, round 4. We're almost getting there. Okay. For flights, there's a 30% chance a flight will be delayed because of icy weather. If a flight is delayed because of icy weather, there's a 10% chance the flight will also be delayed because of mechanical problem. Okay, Will, yep, I love it. First time chats. Okay, so icy weather. If there's icy weather, they told you there's a 10% chance the flight will be delayed. This is perfect for a tree because it sounds like the icy weather comes first and then the mechanical delay depends on that, and it comes second. So that's why this one leans me to a tree. So I'm going to do icy weather first, level of the tree, and then the second level of the tree, I'm going to do a mechanical delay, or not. And then you might have no icy weather, but you still might have a mechanical delay. Oops, why did I put a D? A B. Okay, I mean a D, B, whatever, I can't talk. Okay, so let's see. Let's fill in the numbers here. So we got 30% chance delayed from icy weather. 30% chance we get delayed from icy weather. So that means there's a 70% chance you do not. Next level, 10% chance flight gets delayed because of mechanical if there's icy weather. So this branch right here is your 10%. If the flight is not delayed because of icy weather, there's only a 5% chance it'll be delayed for mechanical. So 5% for that one. So the not getting delayed from icy weather is 90%. The not getting delayed for that one is 95%. You have filled out the tree. Now, if they ever ask you if mechanical delays and ice delays are dependent or independent, you don't have to calculate anything on this one. You just have to look at these two numbers. This is the number that you will mechanical delay given you're in icy weather. This is the number you have a mechanical delay given you're not in icy weather. Are they the same? If they're the same, it doesn't matter if you have icy weather. That would be independence. If these two are different, then it does matter whether you have icy weather or not, so that would be dependent. That's how you can see it on a tree. So these are obviously dependent instances, but if we want to find, what do they ask you? They ask you the probability that the flight will have at least one of the two types of delays. At least one. Rice rat. Thank you for the bits. Thank you for the bits. I gotta say it like the professionals. Thank you for the bits. Okay. Um, so I got distracted by the bits. The probability that the flight selected will have at least one of the two types of delays. So one of the two, at least one. That means it could have one or it could have both. There's three branches up here that do one delay or both. Okay. Icy mechanical, there's both delays. Icy, no mechanical. That's one delay. No icy, but mechanical. There's another one delay. So you could do all three of those branches, you guys. You have the tree here. You could do all three, add them up. You have that one. The quickest way to do this problem, it is an at least problem. And what do we say when we have at least ones? The quickest way is to do the opposite. So don't do the three branches. You can. It's not going to take you that much longer. But it'd be quicker if you do the no delay branch, because there's only one branch on here where you didn't have either delay. And that's this bottom branch down here. So the 0.70 times the 0.95. If you multiply those two, that's the no delay. 1 minus that, boom, you have the answer. 1 minus 0.665, you get 0.335. So it looks like the answer is B. I always like to see what answers they have here. They have the one before you subtracted is there. Oh, there's only one way of no delay because you need no delay on the first branch and then there's no delay on the second branch. If you look at all the other branches, they have at least one delay. So like this one had both delays. This branch had icy delay but not mechanical. This branch had no icy, but it had a mechanical. This is the branch that didn't have icy or mechanical. So you can sort of see that right there. Okay, so good question, right? It's hard sometimes. This one's nice. There's only four sections. Yes, they're I'm wording it icy weather, but they're saying it's delayed icy weather. These are numbers for icy weather delay. I should have called it icy delay. Um, okay, notice this answer is the one before you subtracted. So if you just did this branch, that answer is going to show up. I would bet, here's my thinking. I bet you the branch, if you do one delay, so this one and this one, I wonder if those two show up because I think they're tricky like that. Let's see. Let's see. If we do the 0.3 times the 0.9, that's the one delay on that branch. On the other branch, it'd be 0.7 times 0.05. I want to see if they're this mean. So if you take that one and add it to that one, 0.305, did that show up? They did not. Okay, so they weren't that mean. They weren't that mean. That would have been one that probably a lot of people picked if it showed up there because you got one delay and you forgot there's a two delay one. What else did they have show up? 0.3 times 0.1. So there's the top branch. 0.03 is the top branch. That didn't show up either. Let's add that one to that one. Well, that would be the answer. What? I did all the three branches. What did I think? That was the answer. Okay, but so I'm trying to figure out where the other ones are coming from, but I obviously am not figuring out. This one I think could get picked. Um, Espen, Espen, subscriber. Thanks for the subscription, Espen. Love it. Love it. Okay. So I think this one might be a commonly wrong picked one, but you know, um, I don't know where the other ones are coming from. Sometimes until you guys do it in class, it's hard for me to sometimes see where the other ones are coming from. So, it's tough. It's tough. Um, okay, so there's that one. I know there were a lot of questions on this one. This one is a tough one. Um, if I was to put questions like this on your test, there would not be a significant amount of them. Like if I give you 20, 25 questions on this test, and I'm trying to pick out questions for this test, this one I know is tough. I read through it, I understand it's a tough problem. I would say, four, you might run into four that I consider tough problems. So yeah, so don't, don't worry. You're not gonna have a whole test of really tough ones. But on the review, I was like, I should give you guys tough ones. So you will have some easy ones where you're like, really? It's that easy? Yeah, it's really that easy on some of them, you guys. Don't freak out. Okay, next one, number 5. Oh, I think you guys like this one. I don't think this one was a really struggle for most of you. So table, elementary school, they asked which emotion they saw when they saw the painting. Here's their different age levels. Here's the emotion they felt. One student from the school will be selected at random. What is the probability that that student is in the age group 6 to 8, given that they said joy? So they are in the 6 to 8 category, given that they said joy. So you are only looking in the joy. Why am I thinking inside out right now? Joy, Leslie, nope. No. Okay, so you're only looking in this column. So you're in that column. Well, that tells you you have 89 people in that column. And then how many are 6 to 8? Well, there are 28 in there that are 6 to 8. You're done. 28 out of 89. I don't even see that answer. Let's see. We got to scroll down. 28 out of 89. There it is. Answer choice E. 28 out of 89. They're hiding it down there last. All these other ones are different ones. Most of them, 3 of them were out of the whole group. Who did the right number? 28 out of 332, common wrong answer. B would be a really common wrong answer someone would pick. Someone reverses it. What if they do 6 for 8 group joy people? That'd be 106 on the bottom, and they pick 28 on top. There's answer C. So answer C is if you reverse your given probability. So that's the thing. I gave you half credit on the quiz today if you reversed it. On multiple choice, it's going to be wrong, and they probably will have those there. So just be careful. Write the notation. It helps. Write the notation. What's my favorite color? My favorite color, yeah, purple. I like purple. Purple's nice. I like turquoise, blue. I just picked easy colors on here. Yellow. I don't know why yellow's on here because yellow really is a terrible color to write with. Look at that color. You barely see that. That's a terrible color to write with. Okay. So we shouldn't even have yellow on a choice. But maybe if I had a dark background, that's why I have yellow on there. That's probably why. Okay. So let's put some purple. Let's do a purple. That's a nice purple. There we go. Now we have a purple pen. Okay. So let's go to the next page. We're almost done. We're on question 6. Henzo Benzo Wens. Let's go. Henzo Benzo Wens. That's a crazy name there. Thanks for the subscription. Enjoy, enjoy. Okay, here we go. Oh, basically this is a chapter 14 problem. So see, this was actually out of 14, but Sometimes the wording can be tricky. Large stores, people ask for help. According to store records, 1/4 of all customers who go to the service firm ask for help finding an item. So the chance that they will ask for help finding an item will be 1/4. Chance that they will ask for help. Okay, let's check. Um, Assume the reason each customer goes to service firm is independent. So that's key. They always will tell you that because we can't really do all our calculations sometimes without independence. That just means you can multiply and you don't have to worry about probabilities changing. Based on the approximation, what is the probability that at least one of the next four, so at least one, that's your code word, of the next four who go to the service front will ask for help finding an item. So you'd have to do one finds, two, three, four. I don't want to do all that. So let's do one minus the probability that none ask for help finding an item. We have four people coming. If 1/4 chance they do ask for help finding an item, what is the chance they don't ask for help finding an item? Someone out there in the chat, throw it in. 1/4 chance they ask for help finding an item. What's the chance they don't ask for help finding an item? See, oh, you already give me the answer. You're going ahead. Will, you're going ahead. Okay, so 3/4. I know you were thinking that. Perfect. Henzo, Benzo, Wenzo. Okay, 3/4 for that. You're going to do that. You're going to have four of them because all four people are not going to ask for help. And then you're going to do one minus that. So that should be everything else. So 3/4 to the fourth, one minus 3/4. Oh, we don't need to calculate it. They left it all. They didn't even calculate it. What am I doing? What am I doing? Right, there it is. Will, you were right. It is C. Let's look at their common ones. I'm trying to look at their answers here. This is the one where you forgot to flip it. So those of you, that would be four people asking for help and then opposite. So opposite of four people asking for help is like three ask for help, two ask for help, one ask for help, or none ask for help. That's the opposite. So that's a common. This one, that's people that don't understand. You got to multiply. Got to Jocher subscription. Thank you. Woo! Everybody's subscribing. You don't have to do that, guys. There is no subscription. I don't do this for money. I do this just to help you out. So this is the this should have been the power, right? We don't multiply by four. We put 1/4 to the fourth. So that's just them trying to mess with you. This sort of looks like something you don't know about yet. This is their binomial expansion. Don't worry about that yet. That's later. That's later, chapter 17. And this is if the probability somehow changes. But we didn't have probabilities were independent on this one, so you're not worrying about them changing. So, okay. Next one, number 7. Okay, here we go. Probably that particular component. This, I think I gave you I think I accidentally gave you a second problem that was the same as that other one. Let's see. It looks pretty similar to that first one we did. Successfully is 3/4, so probability that it's going to keep working is going to be 3/4. Okay. Three components operate independently. See, it sounds a lot like problem 1. System will function successfully if at least one of the three, oh, they changed it a little bit. One of the three has to work, so the other two can break. As long as one is still working, it will work. What's the probability? VTX Bone, you got a subscription. Thank you. What is the probability that the system will function successfully? So at least one needs to work. So they basically said to you, hey, out of your three, what's the probability that at least one works? W teach, yes. Okay, at least one works. So probably at least one works. We're going to have, let's do the opposite. Probability that none work. So because I don't really want to do one working and then two working and then three working. Too much work. So let's do none working. So first one doesn't work. That's 1/4. Second one doesn't work. 1/4. Third one doesn't work. 1/4. There's the chance that all of them don't work. And then 1 minus that. Of course, they didn't do decimals. So 1/4, 1/4, 1/4. What is 4 to the third? 4 to the third is 64. Yes, I need a calculator to do that. So 1 over 64, 1 minus that. So common denominators, 64 over 64 minus 1 over 64. You should be looking for 63 over 64. And if you're not good with fractions, it's not a big deal. Turn it into a decimal. Check these with your decimals. One of them's going to match. You're totally good. Okay? You can totally do it with decimals. Who cares? Okay, so there's that one. Very similar to the first one, but slightly different. They changed a little bit of the problem. Okay, next one, number 8, is another one with a table. Table ones I like, but the table ones are easy to pick wrong answers because they will put the common wrong answers on the table. So just be prepared. They will be there. The ones that you're like, oh, I'm going to pick that one. Yeah, it will be there. So here we go. Probability. Um, One senior from the high schools will be selected. What is probably that the senior selected will not be from high school B, given senior responded with choice other than college? So, um, probability they're not from B. Again, you guys, this is why my notation helps me. Given that they said not college, basically. Anything else? Didn't say what it had to be, but it's not college. So, when you look at this table, these two are not college. This one is not college. Don't look at the college column. So we know the bottom number will be your not college. So 244, 106, 188. 244, 106, 188. I guess I could have done the opposite. I mean, I guess it would have been better if I did 956 minus 418. Whatever. I didn't see it like that in my brain. But you're right. You're thinking Mr. Shevlin has said at least. You should have done opposite. Yeah, I should have done opposite. So 538, when I add those up, so you get 538 for the bottom number. And then the top number, um, not from B, but not from B would be 99, 83, 49, 31, 63, 71. It's a lot to add. So 99 plus 83 plus 49 plus 31 plus 63 plus 71. You add those all up, that should be the top number. 99, make sure I type this right, 83, 49, 31, 63, 71. Add them. I get 396 on top. Now it'd be awesome if that number was actually here. It might need to be reduced. Let's see if it's here. Oh my gosh, it is here. E. I was hoping it would be there. Yes, it is E. Answer choice E. I probably can't see it because my screen cut it off, but it is answer choice E on this one. Where's my hand? Oh, shoot. Go back and then go back again. So answer choice E, that is your one. Notice they have a lot of 956 on the bottom. There's a 418, so there is, one of them was the college group. And that was probably, that might be one that people pick because you'll probably add this one and this one and put it over 418. That's probably that one right there. So a lot of ways to get it wrong on this one. 8 is just tables can be tricky like that. Read carefully on tables. Write your notation on tables. Helps a lot. Okay, number 9. Hours. Oh, this is one of my favorites, but this is a really hard one. Oh, but it's one of my favorites. Okay, so it brings back your normal approximation. The distribution number of hours worked by volunteers at a large hospital is approximately normal, with a mean of 80 and a standard deviation of 7. So here are the hours volunteered. Mean is 80, standard deviation is 7 hours. Okay. Volunteers in the top 20% will get a certificate. If you're in the top 20%, you get a certificate. We don't really care where that is right now. We just need to know it's top 20%. If a volunteer from last year is selected at random, which of the following is the closest to the probability that the volunteer selected will receive a certificate given the number of hours the volunteer worked is less than 90? So they worked less than 90 hours. That is what they want you to calculate, which means you guys need to figure out first the probability that someone worked less than 90 hours. The given has to be done first. So that is your review. Go to your calculator, normal CDF. We're going to go lower boundary. You could put 0, you could put negative infinity, it doesn't matter. Upper boundary is going to be 90, right? We're going to go way out here somewhere, 90, and we're going to calculate the area less than that. So 90 is your upper boundary. Your mean, we already know, was 80. Your standard deviation was 7. Go to your calculator, type that in. Let's see what we get. Normal CDF. I'm just going to leave in negative infinity, 90, 80, and 7. And that will give you 0.9234. So the area less than 90, this whole part right here, right? 0.9234. Okay, so you know that. That's the area less than 90. That's going to be the bottom number. Okay. Normal CDF, Carson, normal CDF might come up on a problem or two. Okay. So maybe, like I'm going to put some review problems. Normal is something that stays with us the whole year. I never actually want you to forget normal. So just, you never know when you're going to do normal CDF. Those of you who are Z-score people and use the table, great. You're going to do your Z-score, 90 minus 80, and you're going to divide by 7, and you're going to get the Z-score, and you're going to go to your table, and you're going to look up that Z-score. It's 1.43. So if you go to your table, you look up 1.43, you will get an answer very close to 92%. So area less than there, 92%. Boom. That's the bottom number. So we got the bottom number. Okay, now you guys got to figure out the top number. Remember, the top number should be the percent of people that get a certificate and work less than 90 hours. Percent of people that get a certificate. Remember, the top is your and. Certificate and less than 90 hours. That's the top. So we know the percentage that work less than 90 hours. That's 92%. They told you certificates are top 20%. So that means this part, right? 20%. Well, these are the people in this dark area right here that are getting a certificate and are less than 92%. right? Or less than 90, I mean. These are the people that are less than 90 and are in the top 20%. So if you know this is 92%, and you know this from here down is 80%, because if you're in the top 20%, that means 80% is below you. If you do 92% minus 80%, you know how many were in that dark region. So there is about 12% in the dark region. 1234, 0.1234. So the top number is the 0.1234. And once you get that, you are good to go, divided by this number. So the answer is 0.1337-ish. There's got to be one close to it. There it is. Theirs is probably using the table, and that's why their number is a little bit different than our number. We're doing it very exact. They probably use the table. So yeah, normal CDF could be. It's probably not going to be on more than one problem, but it could be. It can even come up on FRQs, you guys. So that kind of stuff. Just be ready. Look up your normal CDF command again. Remember how to hit it. You're going to go second variable button, normal CDF. Never use normal PDF, always normal CDF. Inverse norm, not as often. That's when I give you the area and you're going backwards. That's probably not likely to happen on this because most of our problems were calculating probabilities. So probably you're going to be using normal CDF because that's a probability because it's the area under the curve. So you're probably not doing inverse norm very much for a while. So there's number 9. Thank you for the chats and the questions, you guys. We're on the last problem, and then I can clip this and then I'll put it in Google Classroom tonight. So 51 minutes longer. I thought it was going to be like 30 minutes, but I talk too much. So I get it. 9:30 here. Clark drives his way to work. Oh, this is a fun one. This is what I imagine when I'm driving to work. Clark drives through 2 traffic lights on his way to work. He estimates that the probability that the first light will be red to be 0.3. Chat, clip that. Okay, first one is red. It's going to be 0.3. So that's the first light. And then the second light is going to be 0.45. The lights are far enough apart that they can be considered to be independent. Ooh, that's a big deal for us. So if you wanted to do the chance that both lights are red, you could just multiply 0.3 and 0.45 because they said they're independent. Based on Clark's estimates, what is the probability that at least one of the 2 lights will be red? So at least one red. You guys know what to do. This is your famous chapter 14 problems. At least one, do the opposite. 1 minus, no reds for either light. So the chance that the first one is not red, 0.7. Chance that the second one is not red, 0.55. Make sure my numbers are right. Yeah, 0.55, second one not red. 1 minus that should give you the answer. 0.7, 0.55, that's 0.385. 1 minus 0.385 is 0.615. So your answer is this one. Notice 0.385 is there. So if you forgot to do opposite and you just did no red lights, that would be the one you probably picked. You could also do a tree diagram on this if you wanted to actually see the visuals of everything. Red light on the first one, not red on the first one. Red light on the second one, not red on the second one. Red on the second one, not red on the second one. And there you go. That's everything that can happen. Chance of it being red on the first light, 0.3. Chance of it not being red, 0.7. Second light, chance of it being red, 0.45. Chance of it not being red, 0.55. Notice that these are the same. 0.45, 0.55, because they told you these were independent. So that is why this probability is the same as this probability. The first light did not affect the second light. So you don't see a difference in probability. When you're going live on Fortnite, after this, I'll go live on Fortnite. I'll play a game, but I'm probably going to lose. I've been playing bad. I even tried zero build yesterday and still didn't win. It's so depressing. Okay, so you could do the tree, and then they asked you to figure out that probably at least one of the lights is red. So if you were doing at least one and you didn't want to do opposites, you would do this branch, this branch, this branch. Add up all three of those, and you would have 0.615. We did the not branch and did one minus that opposite. So hopefully that's good, you guys. We got everything done. We got the work done. I'll put a YouTube video of this on. You guys are welcome. I'll put a YouTube video on Google Classroom. So anyone that didn't show up, you talk to them, tell them the video is on YouTube.